So this next video is 4.1.2 on constructions, so geometric constructions. This quiz that you'll be taking in Apex talks a lot about Euclidean geometry. Euclidean geometry was created by a Greek mathematician by the name of Euclid. There are some pictures for you. So you can see, if you can read this one, it says Euclid, the father of geometry. He wrote a book on geometry, so there's kind of a picture to give you an idea. Oh, whoops, sorry. Where is it? There it is. Nope, there. There's a picture to give you an idea of a book that he wrote. And he wrote in this book some postulates for geometry that are still kind of used today. And the Greeks back in the time used these postulates to create all sorts of shapes. But before we get into that, let's talk about what those postulates are. So there are 5 postulates that were used. Hopefully you can read this. Oh, there we go. Okay, postulate number 1. A straight line segment can be drawn between any 2 points. Postulate number 2. Any straight line segment can be extended indefinitely. Number 3, a circle can be drawn with any center and radius. 4, all right angles are equal to one another. 5, through a point not on a given line, there is exactly one line parallel to the given line. Okay, so that's often known as the parallel postulate. It's actually worded a little bit differently, or Euclid worded it a little bit differently, but for your Apex quiz, you're basically going to know that given any line, then there's a line parallel to that given line. Even if you're given a line and a point not on that line, then we can draw a line through the given point to be parallel to your original line. It all works out. There are parallel lines all over the place. Okay, so the Greeks were able to use those 5 postulates to create shapes. They used the theories behind them to create shapes, and the only tools that they used were a straight edge, which today we tend to typically call a ruler. So a straight edge and a compass. They used these 2 tools to create multitudes of shapes. They created equilateral triangles, hexagons, octagons, pentagons, square, all sorts of shapes. You will definitely need to know for your quiz that they were able to create more than 5 shapes. Okay. They were also able to create angles and bisect them. We've actually done this. You probably don't recall it, but when we created our little art project, our tessellation art project, you were able to draw the little, it kind of looked like a little lunar shape and cut through, and we were angle bisecting and creating equilateral triangles and stuff to create our little tessellating tile. Okay, so that's the same idea that the Greeks would use to create their shapes. They were able to also create circles, and, well, obviously circles because of the compass. But using the circles, they were able to create equilateral triangles. Let's see. Oh, I don't want to forget this. Perpendicular bisectors for a line segment can also be done using a compass and a straight edge. So angle bisectors, perpendicular bisectors, all using a compass and straight edge. Okay, so I'm going to walk you through an example of how they would create an equilateral triangle. So given a line segment, AB, okay, so I see my paper's just blank. I'm going to draw a line segment of A and B on here using my straight edge. Okay, here's my line segment A and B. Given this, I am now going to use A as the center of a circle and B, oh, this line segment is too long. Hold on, we gotta go a little bit smaller. I can see that there will be problems using that. Okay, nothing like making a mistake I could tell this would be too long because this is going to be the radius of our circle. So if you extended it out here, it would not fit on the paper. So I'm like, uh-oh, I've got to try again. So I'm going to try a smaller one. So this is now my radius. I'm going to draw a circle using B as the center and A as the center. So that those two circles should be able to fit on this paper now. So I'm going to grab my compass and I'm going to put the needle point on A and extend it across to B and then circle it around, and I will flip and go the other way with B as the center. So just a moment while I do that. So my needle is on A. I'm extending the compass so that the part with the lead gets to B. Okay, there we go. And now I'm going to circle this around. Whoops. Don't mind me. Even teachers make mistakes. Okay, so it's kind of faint, but there's my first circle. Hopefully you can see that. So I'm going to now draw my second circle. So rather than A being the center point, B is now the center point. So I put the needle point on A, and it should already be the width of the line segment. It is. So I'm going to draw my second circle. Whoops. Here we go. Okay, so there are my two circles. A little wobbly on circle B. So this is circle A on this side. This is circle B. They look like a Venn diagram. It's exactly how we want it. So now you'll see here, I have an intersection where my two circles cross. I'm going to mark that and call it point C. Okay, so there's point C. So I'm going to now use my straight edge and draw a line from A to C and a line from B to C. So I can get 3 line segments. Okay, here are my line segments. I now have a triangle, and I am going to tell you that this triangle is equilateral. Now you can trust me, but the question is why? Why can you trust me? Why is this an equilateral triangle? If you look at the original line segment A to B, let's just focus on circle A, okay? Circle A, in circle A, the line segment A to B is a radius. Okay, so this is a radius. Of circle A, and you'll see circle, to represent circle A, they draw a circle with a dot in the center, and then the letter or the name, the center point of the circle to name it. So this is a radius of circle A. It's also a radius of circle B, but we're focusing on circle A. So if we go from A to C, it starts in the center, this line segment, and it goes to the outer edge, or the circumference part of the circle. So that also is a radius of circle A. Okay, so we have 2 radius of circle A. All radii of any given circle are, whoops, I wrote that on the wrong one. Gosh, guys, I'm really good at making mistakes, aren't I? That's okay. That's what happens in life. Okay, so we have radius of circle A, radius of circle A. All radii in any circle, even circle A, are equal. And since they are equal, that means these two sides are also equal. We could do the same by saying in circle B, the line segment AB is a radius of circle B. The line segment BC is a radius of circle B. So therefore, these two sides are equal. Then really it's by the transitive property. Since AB is equal to AC and AB is equal to BC, that means AB and BC are equal. So all 3 sides equal one another. Therefore, it is an equilateral triangle. That is all you need to know for your quiz, but I'll also say that equilateral triangles are equiangular. Just keep that in mind. If you have any further questions for this quiz, let me know. I wish you the best of luck.